get a Python shell going in your terminal? Awesome. If you go to your terminal application, the one called terminal, you can access it, command space, it'll pull up the terminal bar, the spotlight bar, go to terminal. If you just type the word Python and hit enter, you can start writing some Python. So, yes, Ignat?
We're using Python 3.
We're using Python 3.5.
Yes.
Yeah, the latest version.
If you haven't finished the installation instructions from the Install Fest last night, run through them. If you run into problems, come grab me or Daniel. We definitely want to all be using Python 3.5 for this.
If you've updated your installation correctly, then if you type Python on terminal, it should default to the latest version. No, it doesn't?
You can always type, yeah,
Oh,
Python 3.
Then you're right. You have to type Python 3, and then it'll default to the latest version of Python 3, which is 3.5.
If you have any doubts, you can type Python -- version or Python 3 -- version.
Yeah. So for the reason the terminal is useful in that regard is a lot of the time you're going to want to test out small things. Maybe as you're learning, you don't remember the syntax for something. You don't want to include it in your project and then have an error in there that's more difficult to debug. You can just open the terminal, type Python space 3, get a Python shell, and then just start typing there and experimenting, manipulating, make sure you have things right, and then put those into your project. So this is a very, very bird's eye overview of Python, and we will be sending you slides that are a more detailed version of this. I modified them because they were too hard to read on this screen. So some detail has been lost for this live presentation, but you're going to get a written version with all the good stuff spelled out. So Python at its core is a scripting language that is interpreted, meaning there is no dedicated compile step in Python by default. Now, you can compile a Python file, and the output is something that will run more efficiently than your interpreted source code, but Python can be run line by line, which is why you're able to pull up an interactive Python shell in your terminal and interact with the code that you've written. The interpreter is smart and will not reinterpret or recompile things that haven't changed. And so even in your Python shell in terminal, you can define certain functions and then refer to them later. And as long as it's within the same terminal session, you haven't closed it, the terminal window will remember the state, variables you've declared, functions you've declared that you can reuse later. The nice thing about Python is that it has no type declarations, which makes it a great learning language. And actually, it's starting more and more to supersede Java, both at the high school and university level across the world, as the teaching language of choice. Here's a simple sort of hello world as it would look like in the Python shell. Python is used for a lot of things. It's gotten a big, big following in everything that is machine learning and big data analysis, but also is very prominent in the application of in the development of web applications. As far as I know, there isn't a competitive or mainstream solution for using Python to develop desktop or mobile applications that is commercially prevalent. But on the back end for your web services, Python is a very strong player, very commonly used. The most popular frameworks for that, Flask and Django, are ones that you will find used at a bunch of companies you've heard of. And as Alan was saying, our partner Lyft is using Flask. I found out last night from a housemate of mine who works at Lyft that the unadvertised truth is that they have a lot of PHP legacy code still in their back end, but everything that's new and a lot of the code has been converted to Python, and that's what new developers are primarily working on. You can really use it for anything. It's not limited in its use. However, there's certain tasks that are considered to be better suited for Python, others better suited for other languages. The quirk of Python that makes it notably different from languages you might have used if you are new to Python is that whitespace matters and is the frequent source of bugs that really trip up new developers. This is an important stylistic point that actually everyone has to listen to. So even if you're looking at your laptop, look up at me right now and make eye contact so that you signal that you're listening. Even Nick needs to know. We're using 4 spaces for indentation instead of tabs. 4 spaces instead of tabs. So when you create a new line, you want to indent space, 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 not tab. Yes? Yeah. Yeah. No, for like everything. For like your source code files. 4 spaces, not tab. Yes. So in Atom, it'll do it automatically for you, but you need to keep that in the back of your mind. A very common mistake could be like doing some scratch work in the terminal, trying to paste it back in, stuff like that. Be just very, very sensitive to making sure that at its core, post IDE fanciness, you have 4 spaces and not tabs. If you didn't follow what Nick said, you missed a step in the installathon where you're supposed to turn on the tab to space conversion in Atom. So if that doesn't ring a bell, then double check with an instructor and make sure you did it. And so scope is defined with indentation. Every statement that defines a scope that we are familiar with in programming, so function declarations or method declarations, conditional statements, if else, loops, things like that are all going to be followed by an indented block which represents everything that is in the scope of that statement. So the moment that you exit out of a function or an if statement or a loop is the moment that you exit, you go back 1 level of indentation. So here's a sample function that will calculate a factorial. You have the function declaration, indentation after that, a conditional indentation after that, right? The return statement at the very end, same level as the conditionals because it's not nested within any one of them, so it's the last thing that happens. If you don't return in either previous one, then you're going to return at the very last line. But it still has to be indented. If it wasn't, it would not be part of the function. Very common source of errors, first thing you should be looking at if Python is misbehaving, did I get my indentations right? And be disciplined about doing these in a way that is consistent because over large projects and large files, one errant indent can confuse the program and have repercussions where the error actually only gets flagged much later in the file and really, really confuse you. So if there's inconsistent behavior that you can't track down, see if you can find the indentation mistake. Atom should really help with this and is not crap like idle, which was the IDE that Luke and I both had to use to learn Python back in the day. So quick discussion of Python types. Python does not have a built-in array type. Instead, Python uses, we're starting with strings. Strings have a lot of manipulations built into them that can be done in the same way that you'd expect to manipulate arrays in other programming languages. You can use single quotes or double quotes, and there is no distinction in Python, but be consistent in your code. And don't freak out if you read someone else's sample code that uses a different convention. You can concatenate strings with a plus operator, and it doesn't matter whether one was a single quoted and one was a double quoted, it'll just work. And you can access characters by index in the same way you'd expect accessing things by index in an array. So could someone tell me what full sub 3 would be here? Yes? L? No. Full sub 3, yes? No. Index from E, there you go. E. Index from 0, full is Jeremy Rossman with no space in between. We index from 0, so the 4th letter in colloquial speak is the E. We can slice strings. This is a syntax that if you spot it and you don't know it, looks magical and confusing. So if you don't know how to slice strings in Python, you can define a range with 2 numbers separated by a full colon, not a semicolon. If you omit one of the numbers, then it will default to the maximum or minimum that it can possibly be. So if I slice blank colon 6, I'm doing implicitly 0 to 6. If I slice 6 colon blank, I'm doing 6 to end. And the way that these are set up, if we count, Jeremy is 0, 1, 2, 3, 4, 5. So there's 6 letters, but the 5th one, or the last one is at index 5. But with slicing, it's exclusive. So slicing 0 to 6 will return letters 0, 1, 2, 3, 4, 5. So it'll return the first 6 letters, but ending at the 5th index. So the way that we've set it up, because Jeremy has 6 letters, first equals full with this type of slice will return only Jeremy out of Jeremy Rossman. Last equals full with that slice will return Rossman only. Yes?
For Pep 8, for strings,
Do you know what the preferred way is? Double quotes, but Daniel doesn't believe in it. The reason that I prefer double quotes is that it makes it abundantly clear when you have an escaped single quote within, if you're using like I'm, I apostrophe S, like a string. We'll talk about escapes, right there. But the official preference is double quotes. It's up to you. Consistency is key. Yeah. Yes?
What if you use a double quote and then use single quotes inside of it and the double quote? Is that inside of the greater string or is that a string within?
Right, very good question. So if you have single quotes within double quotes, you're going to get inconsistent behavior unless you use the backslash to escape. You can't really have like a string within a string. It's going to get confused and it's going to draw the boundaries between the first pairs of quotes and so leave a bunch of stuff in between that is not recognizing. The special character backslash here will not be rendered if the string is ever printed or accessed. It's not actually something that's there, but it allows you to have a quote within your string that is not tripping up the interpreter and is being treated as a character within the string as opposed to meaning for Python. Does that make sense? So there's many, many more operations you can do with strings. The details, some of them are in the slides, version of the slides you will get, which will have more code in them than these big examples, but all of it is in the Python documentation. When you look at the Python documentation, a warning, Python 2.7 has better SEO than Python 3.5. So if you look at Python list documentation, the first link is probably going to be the 2.7 documentation. And there are subtle differences that will really, really trip you up if you're looking at the wrong version. Some function names have been subtly renamed, or even ones with the same name have subtly different behavior now in the new version of Python. You need to be sure you're looking at the right documentation. Every type in Python, strings, lists, and so on, have a full list of all the functions that are built in for them. And so Python documentation is hyper easy to navigate and really, really useful. And it is normal, 100% normal, to not have these things committed to memory for the next 2 weeks and to have a tab open all the time where you're constantly checking. And even where you're testing your own recall of your syntax by trying it in the terminal real quick, making sure it works before writing it into your file. Next, we have lists. So I was saying Python doesn't have a built-in array type. Arrays traditionally in other programming languages will only be able to store multiple items of the same type, whereas lists can store items of different types. So you can have integers, strings, variables, whatever you'd like, all within a list. A list is declared by using square brackets on the ends and comma separating values. Remember that Python is dynamically typed. It has type inference. So if I say stuff equals, and then right here is something that looks like a list, well, stuff can be a list. But later, I could say stuff equals 3, and then all of a sudden, stuff will get overwritten to be an integer. So Python is both really permissive, which is great, and as a result, problematically loose when it comes to debugging, because it won't throw errors. It'll just crash your program when it's running if you have some sort of type mismatch. Indexing starts at 0. You can access stuff the same way you would as strings, what you're used to in other languages. A fun thing is you can count backwards with negative indices. So stuff sub -1 is going to return actually the last item there, and then -2 will start counting back. So the list is 0 indexed from the beginning and -1 indexed from the end. Kind of bizarre. You can test out this behavior in the terminal if you want to see how that works. And the important thing about lists is that they are mutable. You can change them, you can reorder them, you can add things to them, you can remove things from them, all the stuff you'd expect from a mutable object. As a result, they aren't the most efficient because the way they're represented in memory has to allow for an unknown size, mutable contents. And so they aren't the most efficient choice if you are going to have an unchanged set of data. You should also know that by convention, in Python, whenever we can, we try to use lists to represent homogeneous sets of information, so things that are all the same type. And I'll introduce a type later that is more traditionally used for collections of different types. One of the reasons for this is that lists are ordered. They always carry an order. Now, if you create them like this, well, it's obviously unordered, but you can sort them. So let's see some of the built-in things that lists allow us to do. I can append something, a new thing. It'll get added at the end of the list. I can remove something by element. it will search through the list, find the first instance of what I'm showing it, and remove it, but it will not remove all instances. So a fun little challenge for you could be write a very short program that removes all instances of an object in a list. Maybe you have a list that is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. How do you remove all the 3s? And then if you want a further challenge, how would you write a short little code snippet that removes only the first 2 instances or first n instances of something in a list? If you want to remove something by index as opposed to by element, saying I want to remove this second thing, well, this would actually be the third item, right, since we're 0 indexed. You can use the pop function instead of the remove, and that'll just remove whatever's at that index, and then again, resize the list accordingly. You can sort it with sort, stuff.sort. It will sort the list in place, so it modifies the original list. Sorting occurs with numbers first, and then strings alphabetically. I don't know off the top of my head how it treats data structures, because you can have within a list other lists and things like that, but the sorting function has a default way to do it that it'll return for you. If you want a new sorted copy of the list that does not modify the original, there's another function called sorted, which you would call on the entire list. So instead of doing stuff.sort, you could do sorted and pass in as a parameter your original list, and you would get back a new copy of a sorted list without modifying the original. And then the length of the list, unlike some languages, a very common mistake from folks who come from Java is they try to do list.length. It doesn't work. You have to call the built-in len function and pass in as a parameter the list. So this is very common, like frustration. If you're have another language in the top of your mind and the functions are very similar sounding, remember sort versus sorted, and then len and not dot length. So this is stuff that will not work with immutable types. Yes? Question? Igna? It should feel a little bit like Swift. Swift is a new language, as you know. Behind the scenes, there's a lot of differences from Python. Even though it does do inferred typing, it is strict about it, so you can't just willy-nilly play around with types. Swift is really strict about what is and isn't mutable, but you have to let it know beforehand, and that's a modifier to given types, whereas in Python, it's built into the type's identity itself. So a list is just a mutable thing. There's no such thing as an immutable list, if that makes sense. You might also be curious to find out that Python behind the scenes is implemented in C. And so if you want to see how the list is implemented in Python, then you can actually read the C behind the scenes, and you'll find that it's actually a C array of pointers. That makes sense to you, awesome. If it doesn't, it will by the end of this program. There are other implementations of Python that are not in C, but the one that we use by default is CPython, and that's what's installed in all of your machines. So kind of an interesting factoid that there's a language built in another language, and you can read the language's source code and find out the source code for each type. So now onto the immutable variant of a list that is fundamentally different. It's called tuples. Tuples are confusing because their name intuitively and instinctively makes people assume that they're a pair of things. Because it sounds like a triple or quadruple, so a tuple must be a pair. And actually, tuples are not a pair. They are an unordered collection of any number of different types that is immutable. So the core difference is you declare them with parentheses instead of square brackets. Parentheses means you got a tuple on your hands. It can, like arrays, it can have multiple different types of data. And in fact, even though it itself is immutable, it can contain mutable types. So within a tuple, you could have a list, and that list is something that you'd be allowed to modify if you accessed it. The tuple would not know that you had modified the list. All the tuple knows is it has an immutable reference to that list, but if you on your own go and change what's inside of there, that's allowed. You can access it and then change it. There's an operation you can do in a tuple called unpacking it, which is the first of many kind of Python magical syntaxes that are difficult to understand if you don't know explicitly what they do. So this Python, number, comma, word, comma, letter equals immutable stuff, will assign number to 5, word to hello, and letter to A. Okay? Whenever you run across syntax in Python that seems magical, that is obviously a shortcut, it's a developer who's gotten used to writing things the more compact way, which is fine. If you knew how to do this, well, you sure would, because it's fewer lines of code, very elegant, very Pythonic, one might say. But it makes your code more difficult to read for beginners, which is not considered a bad thing, but as semi-beginners, some of you, you should not ever run into code like this and just skip over it and go, oh, there's magic there, I don't understand it. You should find an instructor and ask, hey, what is this magic? And how can I use it? And then play around with it in the Python shell. So this is one example of Python magic. There's many other kinds of Python magic that you'll notice in your code. Does this operation make sense? Okay, when do you use a tuple? Captain?
I just want to point out a correction. The tuples are very much ordered. That's a typo on the slide. Lists and tuples are ordered structures. Sets and dictionaries are not ordered.
I'm pretty sure Python tuples are not ordered. Okay, cool. They're ordered. It's a typo. However, you cannot modify them in place. So though you cannot add elements, you cannot remove elements, you cannot sort it in place, you can get a new copy of it that is sorted and things like that. And it's more efficient than lists. So what that means is whenever you're doing something that does not require immutability, you should be using a tuple. This is an interview question potentially, right? When do you use a list? When do you use a tuple? At the scope of the project that you're working on, you will never notice a performance difference if you incorrectly use a list instead of a tuple, unless you're going through large amounts of data. But that moment will come eventually where you're going through your huge corpus, and then we can even time what it's like when you use the wrong type. At an interview question situation or at a company that's dealing with huge amounts of data or scale, it reflects very poorly on you as an engineer if you're cavalier about using a mutable type like a list when you are not actually needing to modify it and you could use a more efficient immutable type. So whenever you don't have to change something, make it a tuple, please. Unlike Swift, Python is not going to hold you to this, is not going to force you to stay up front and then later, catch you if you're being inconsistent. So be careful. However, if you do ever try on a tuple to do any mutations, it'll throw an error instantly. It'll throw an exception. It'll be like, hey, wrong type, you can't do that. So you can try it in your shell right now. You can create a tuple with a few different things on it and try to use any of like .append or .pop or .sort, and it'll throw an error and say, whoa, I can't really do that. Again, we'll have more manipulations you can do with tuples are on the source slides that are going to get sent to you that have a lot more code examples on them, and the documentation has yet way more. Our last type for today, dictionaries. Dictionaries are a pair of keys and values. If you come from a Java background, you might know them as maps. And so they do not have order, but you can access elements in them by key. So here I have a dictionary of issues with dorm rooms. 101, no bed. 301, no fridge. You'll notice the syntax here. Curly bracket. So lists, square bracket. Tuples, parentheses. And dictionaries, curly brackets. The keys and values are separated by colons. So 101 and 301 are the keys, and no bed and no fridge are the values. If I plug in a key to a dictionary, I get back the value. So what would issues sub 101 return? No bed. It would just access that value. You can add new items to a dictionary in Python by simply referring to a key that doesn't yet exist and assigning it to some value. So if you were to look back at issues after this line, you would discover there was a new item in there, and this is the proper syntax to add it. If you access a key that already exists, you're going to override it. And dictionaries are immutable, so you can do that. So you can override an existing key. An important piece of knowledge for the Python world is how to iterate through various data types. Yes, Igna?
Use different types of keys in the dictionary. Like you have key string and key integer and key.
Yes. Yeah. It supports multiple different types, and same thing for the values as well. Yeah. And it is allowed to have a list of dictionaries, each of which has a bunch of key value pairs where the values themselves are either lists or dictionaries. So you can get into these really complicated data structures that you'd almost have to, or not almost, definitely have to draw out on a sheet of paper to keep track of, where you can have a list of dictionaries that each of them have lists and things like that. And that's permitted behavior, which then means, because the Python syntax to access something is always the square bracket appending. Another common issue if you're accessing a value within an array, within a dictionary, within whatever, is if you get the sequence wrong and you're trying to access a string key, but you're accidentally doing it on an array because you miscounted how you're traversing through your data structure, you can get some errors as well. And so a good practice for those of you who are going to be new to this kind of thing is to keep accessing things in different lines for now, to keep it clear in your head what the type is at every stage and to not get confused. Yes, Mike?
Is there a best practice for when accessing a dictionary, double checking that a value does or key value pair does exist? Sort of like an if-let or optionals in Swift, making sure that...
I think, Alan, you have an answer?
There's an in keyword.
Yep.
Special to key to Python. You could say if key indict. Okay. And then like it's a true or false.
And it's a magical keyword where it knows what the type is that you're asking it about. So if you say if A in list, then it knows to check your list to find A. If you say if key indict, it knows to just look at the keys. And how do you find a value in a dictionary? You can iterate through it using the technique in my next slide.
Or you can say if value in
Dict dot items. I think it's dot value. Yeah, dot values.
There's also you can say not. You can say oh if it's not in there then do something special.
Yeah. Everyone follow that? Do you want a summary real quick? So the in keyword returns a Boolean. You can use it in if statement, for example. If A in array, we'll check to see if an object is an array. If key in dict, we'll check all the keys. And if you want to get all the values out of a dictionary, you do dot, not items, dot values, returns a list of all the values, or actually a set, and then it'll return based on that. Now, iteration is a way to do operations on your various lists, dictionaries, and so on. There's different syntax for different things you want to do. So the in keyword is also contextually useful in the context of a for loop. So this would normally return a Boolean if item had some sort of value in the context of an if statement. But the same syntax in the context of a for loop will actually make item an instance variable, or like a variable that's only within the scope of this for loop, that is going to successively be each item in that list. So if I have 5 items in my list, it's going to iterate through 5 times, and each time, item is going to take on a new value, which is the next value in that list. This is considered to be the more Pythonic way and the better accepted way if it works for your needs. Yes?
Is it preferred to use underscore instead of camel case?
Very good question. The convention in Python is to use underscore for variable and function names. Class names, you're going to uppercase, but it's underscore and not camel case in the Python world. Become abundantly evident once you look at all the sample code and everything you see out there.
Yeah, the most important thing is just be consistent within your own project or the libraries you're using. And in Python, underscore is a very good.
Yeah. There's really no other valid option in the Python world. Single quote, double quote, debatable. Underscore variable names, not debatable. Yeah. So now, if you want to get the index within this for loop, there's no way to do it. This construct, this shortcut, does not give you access to the index as you're iterating. And a lot of the times, you want to be able to access each successive item, but also the index. And you don't want to revert to the old school syntax where you're doing I less than whatever. There's a way to do it in Python again with some nice shortcuts. Enumerate is a built-in function and it's going to allow you to access the index and the item in a list. This is the syntax for it, for index comma item. Now remember, these are just variable names. It could be A comma B, but just remember the first one is always going to be the index. The second one is going to be the items in that list. And so here I have a dummy example where I'm taking each item, doing some manipulation on it that I pass in the index to. So this is very useful. Yes, Mike?
Enumerate returns a list or a tuple?
Neither. Neither. It returns a set. No, Alan?
A list of pairs, which are pairs of type of tuple, where it's a key value or index value.
What you'll find if you play around with it in the terminal is that Python has certain manipulations that'll return a construct that doesn't actually contain the information until you need to access it. And so it's very useful to play around with in the terminal first what these things return before attempting to directly access them, because this is, to some degree, a magical shortcut for loop syntax. That's the next one right here. Oh, for key value in dictionary, you would do dot items. That's a Python 3 change. It used to be dot something else, but in Python 3 now it's dot items. So if you did sumdict dot items, then you could do for key comma value and get them, and it would just go through in order all of the key value pairs in that dictionary. Actually, not in order. It will not promise you any order. So it could be different each time you go through it. I want to give you an important caveat here that is the cause of a frequent number of mistakes. You should not be manipulating the list itself when iterating through it. It's a common issue. Imagine that for every time you go through, you append something at the end of the list. You'll get stuck infinitely iterating through a list that grows forever. You can try this in your terminal, and it will never stop. If you do try this in your terminal, and you now think you've crashed your terminal session because it's just going on forever, you can use Control-C, not Command, but Control-C to abort any command that is executing. So you will also run into crashes if you remove items from a list or shorten it in any way while iterating through it, because this construct is only guaranteed to work the way that it's supposed to if the list stays unchanged in size. However, you are allowed to modify objects within the list as long as it doesn't modify the length or properties of the list itself. So just keep that in mind, that you need to be clever about this, and oftentimes if that means that you need to be at the end of your for loop changing the list, you might need to use a temporary variable, load in all the new list stuff in that temporary variable, and then once you've exited your for loop, override the original list with what was in that temporary variable. Yes, Ignat? By reference. By reference. So if you're modifying item, you're modifying what's in the original list, unless it's one of the primitives. Like if it's an integer, then that will not be the case. But if item is a non-primitive, then it'll always be by reference and not by value.
What other things is there any passed by value?
Not by default. Not by default. Everything is going to be passed by reference. So just running through these explicitly, for item in we talked about, for index comma item we talked about as well, and then for dictionaries you can go through, get values in this manner for key in sumdict. Again, key is just a variable. You could write for A in sumdict, it would still know what to do. And if you wanted to get the order keys and values, you would do sumdict.items in parentheses. And that sample code is available both in documentation and in the slides that we'll be sending you in a second. I'm sending a version of these that has smaller text that you couldn't read on the board, but has more information. So it'll be all the same topics in order, just with more detail. And for each type, I skipped over a couple of the less common operators that you might see come up, so make sure to read the slides or the documentation when you see those, or when you get it. Yeah. Anything else about Python? Okay. Functions, declaration syntax for functions, always start with a def. Even if there is going to be no parameter, you're going to leave parentheses at the end, and if there are parameters, they're going to be within here in your declaration. Parameters are going to be comma separated, and you're not required to specify the type. So number here is just a variable name. You could theoretically pass in a string, and then your function would have to deal with it. Function declarations always have a colon at the end of them, as do if statements, as do for loops. So a good handy mental reminder is whenever you're doing something that is going to require a new level of indentation, you also need a colon at the end of the line. And that's another frequent thing to kind of forget to do, especially if you're going back and forth between Swift and Python. These are similar enough that you might forget in one case or add it extraneously in the other. So here's a very simple example of a function that returns 5, another one that accepts a parameter, returns 5 plus that parameter. Works in all the ways that you'd expect from the other programming languages that you know. And what you should know about Python is that functions are actually objects that can be assigned to variable names and that can be manipulated. It's more of an advanced thing that is not really required in most standard projects to manipulate functions as objects, but you should know that if you ever reference a function without the parentheses at the end, Python is going to return to you the object. And so, this is really, really dark. But there's actually brackets around here, and it will even give you where in memory it's being stored. So you'll be able to read this example more clearly in the slides that I sent you. But the key takeaway here is Python will not crash or will not think you did something wrong if you reference a function without parentheses. So even if there's no parameter being passed, you have to add those blank parentheses so it knows you're trying to get a function. Any questions about that? In the more detailed version of the slides that I'll send you, they'll actually go through and assign a function to a variable and then call it later just to fully illustrate how much functions are actually objects. Python does support multiple programming paradigms, yeah. The one that we're going to be using both in the back end, for the iOS app, as well as in this project is going to be primarily object-oriented, but Python does have the flexibility to support multiple different programming paradigms. You tend to see it in object-oriented context because the most popular frameworks for it in use right now are OOP, themed frameworks. Anything to add, Captain?
I was just going to suggest that there's a built-in function called type. And if you're ever iterating through a complex series of things and you want to know what does this thing look like, you just call type on it, the command line, in the context of your code, and it'll print out exactly what it is. Oh, this is a list, and then you can examine inside it. Oh, that's a tuple of 3, that sort of thing. The output looks a lot like this function thing.
Yeah, it'll give you little brackets. Captain, would I call type by passing the variable in to type as a parameter, or does everything have a built-in .type parentheses?
You call type as a function and you pass in the variable you want.
Which is the same way that we do what with arrays, for example, lists, for example. Length, and also getting a new sorted version that doesn't modify the original. Great. Okay, a couple last little housekeeping notes on Python. How to deal with modules and files. So in Python, every program that you're going to write is going to be saved with a .py extension, and you could import code that is in other files. You can specifically import classes and functions that are in other files, and the syntax to do so is right here. So if in triangle.py, I have a function called area that is they did. Okay, so if I have a function called area in triangle.py, I can import a module from file triangle.py. It will look in the same directory and try to find it. If you want to access something that is in a different directory, the usual rules apply for exploring directories in terminal. If you're not familiar with exploring directories in terminal, talk to staff. You probably find a good tutorial just that goes through how to go up and down in directory structure and so on and so forth. But the key here is there's a lot of built-in stuff. And so you're going to be importing external files both from the built-in standard library and from things that you write all the time. When you import another file that contains classes or functions that have a name conflict with what's in your file, you can say import blah, like let's say my function name is sort, right? Import sort as, and then you can give it a new name that does not conflict with your particular file. So you can do import x from x as y from file name, right? So documentation covers this. This is one of the most useful syntaxes to commit to memory. What I find to be particularly helpful whenever I forget is just to peek into another file where I know I did it right to remind myself of the importing syntax. I wanted to point out the import blah as blah because it's confusing if you don't know what that means. Another point of Python magic that you shouldn't just let slip by. You should actually investigate and look up the documentation so you really understand it before you move on.
Yep, so we're going to build our own modules and separate files as we go through the project, so you'll understand it better more and more, and when is the right time to import the whole thing versus importing one function from another module.
And this deals with the software architecture challenges that Alan discussed at the very beginning, introducing the project. It's not immediately obvious, nor should you be expected to intuitively know when it's right to have multiple classes in one file or multiple different files for different classes and how to do your import management. It matters somewhat in this project to keep things organized. It matters hugely in large projects because you end up increasing significantly the memory or performance requirements of running a particular file if you import things that it didn't actually have to import. Because it has to then store reference to all those things and actually make sure it knows what they all mean. And the Python interpreter and compiler is smart enough that when you leave out imports, it is able to take advantage of that fact and be much more efficient in omitting knowledge of things that it doesn't need to know in a particular file. Just stretching. Okay, we're almost done. The standard library in Python is one of the reasons that people like using Python. And you'll find this frequently with various programming languages. Sometimes the thing that makes people like it is not the language itself, but the built-in features or a popular third-party framework for that language. So Ruby is tremendously popular in large part because people like writing Rails, which is a third-party framework that was built on top of Ruby. Sometimes it's third-party, sometimes it's built-in. The standard library, a bunch of built-in stuff that comes bundled with your Python install, and is tremendously valuable, gives Python a lot of its power, and allows you to automatically do a lot of things, which means that you're constantly going to be seeing in other people's code single lines that seem to invoke some function you haven't seen before and produce an amazing result. And so being aware that Python is a very comprehensive standard library is important. You import modules on a per name basis from the standard library. You don't have to memorize these. You can look up all the different modules in the standard library. Common mistake is to forget to import the module in which some function is. So for example, random will give you access to a bunch of functions that will allow you to generate random numbers. The most common one being random.random, but you can also get integers, random.randint, and so on and so forth. Whole slew of built-in ones, but also tons of third-party ones. So when you go through your project, one of the things we're going to look into is how to find and manage installing third-party libraries as you maintain your project. Where this becomes really interesting and challenging in Python projects is that once you start working collaboratively, if you install a third-party library, you've created a dependency in your project where you have files that reference things that are not bundled with Python. And so if someone else just copies all of your code and tries to run it, they won't be able to without having access to that third-party library as well. And so it becomes a software architecture challenge on how do you document properly all the thing that your code depends on, and then how do you correctly replicate that on someone else's machine if they want to get started with your project. Conversely, if you find tutorials online and you're trying to poke around at Python and something doesn't work, the most common culprit is that the code that you found is depending on a library that you don't have installed. And online tutorial writers are very, very, very bad at being disciplined around this because a lot of the time they depend on a third-party library that all of their friends have installed and they installed once 4 years ago and forgot was just not included in default Python. And they've been updating it forever, and so they don't realize that this one line of code will crash for people with a new installation like many of you. So be aware of that. Be aware that those in the room who've written 1,000 or 10,000 lines of Python probably have a lot of built-in packages, and you might want to share with your classmates some of the things you found useful, some of the shortcuts that they allow you to do that are not in the standard library. Make sense? I think we are done. No. Oh, here we go. Pickle is a serialization library that is very, very useful. I encourage you to explore Pickle as your first challenge. If you don't know what it is and you're getting started with Python, understanding just as a practice to go to the documentation, see how you're supposed to import it, find tutorials on how to use it. It's funny because all the frameworks and like apps that are built off of Pickle have stayed thematically similar in name. So there's apps and frameworks like kimchi, radishes, sauerkraut that have been built on top of this built-in library called Pickle. So check it out, part of the standard library. If you don't know what serialization is, it'll be interesting for you to learn as part of understanding what Pickle is. And it's one of the many, many super duper duper powerful libraries in Python. Doing web development in Python without Pickle would be like really, really time consuming and burdensome. And Python is a really heavy philosophy of not reinventing the wheel. And so oftentimes you'll look up a Stack Overflow question. How do I do X in Python? And the answer is two lines, import blah, and then use what you imported. And I'd urge you to appreciate that as a great feature of Python, but also recognize the danger behind that, which is that you become a programmer who knows how to invoke like spells, but doesn't know how they work. And so whenever you use something new, you owe it to yourself to at least know generally where can I find the source code on my machine? Because the Pickle source code is living on your machine right now. Where can I find it? Where can I explore it? And at least if I wanted to find out more, how can I go back and reference that? So don't be just a Python magician who memorizes these like invocations, as is so easy to do because so much online material guides you in that direction. The last thing I'll say is a useful challenge in any language, if you want to explore further, is to re-implement one of the data structures yourself. And so if you're interested understanding how to build a list or a dictionary from scratch using as few of the built-in types as possible, really great way of building an understanding of how things are done. That's pretty hardcore, but secondary to that is at least going and reading the implementation of others, the default implementation, understanding how that works. So these are all some things you can do. I think now we are actually done. The links that you should look at, docs.python.org/3. Remember, 2.7, better SEO, but going to lead you the wrong way. Developers.google.com/edu/python/introduction. Again, these links will be in the slides we send you, but that's a good, really exposition to how Python works and its power. And that's that.